Got them now.
So these answers never change. All right. So this will be your second go around. These first two answers just don't change ever. So the general standard form is y equals, as it always has been, ax squared plus bx plus c. So that would obviously be the first thing I would write on my page of notes right there. Done. And the general vertex form is y equals a times x minus h squared plus k. I'd say, do you have any questions about that? But that's really just a reciting of a formula. So pretty inexcusable to miss that. Number three is something we've practiced, I think, quite a bit. So what I'm going to do first is I'm going to take and I'm going to copy the equation, but I'm going to pull -2 out like this. And then I'm going to rebuild. I'm going to move the -25 out to the back. And then what I do is I take the first two terms and I divide them by the red number that I pulled out. So -2x squared becomes x squared. What does plus 16x become?
What?
Mm-mm.
Oh,
It's not 8x. It is -8x, right? So remember, you're dividing the two terms. I'll put a little box around it for you. You're dividing the two terms in the box by what you pulled out, not the back term. He's sort of exempt from what we're doing here. It keeps things simple. So you divide those both by -2. And then, of course, at this point, we complete the square. And the advice I've always given and will always give is to, when you complete the square, show a little bit of work just because it'll help you down the line. So remember, the algorithm at this point is to take half of that number and write it down. Half of -8 is -4. And then you square that and you get plus 16. So I'm going to add 16 to complete the square. And how do I erase that plus 16 at the back? I have to add 32. Very good. And, I feel like the first time we did that, I remember there was some confusion and chaos as to like, why would you do that? But remember, the real identity of the 16 is -2 times 16. So he's actually a -32, and that's why we offset him the way we did. And then the next thing you write is the final answer. So we just write y equals -2 times something squared, and then do the little kitty math. -25 plus 32 is +7. And then to complete the, or not to complete the square, but to do the factoring step, I've said this, you don't even have to know how to factor that green number that's loitering awkwardly up in the corner. The half of the middle before we squared it is just directly what you copy in. So it's just x minus 4 squared. So that is that. You don't need to state the vertex or anything like that. It's just rewrite it, vertex form, done, game over. Okay. Number four, we're going to use words. And I see three transformations. The missing one this time, if you did the first practice DA, you know that the missing transformation is that there's not a negative right there. And so we can skip having to mention that. So I don't have to say anything. But what I do have to say is that the 1/2 makes the y values go up half as fast, like that. And if that had been a 3, then we would say something like it makes the y values go up 3 times as fast. If it were a negative, then we wouldn't say go up, we would say go down. You can also generalize it and just say change if you don't want to talk about up and down. That's fine as well. So in a case like this, you could even make a little sort of parenthetical additional comment to say like that makes the graph fatter, if you will, because that's kind of how we learned that, is that the fractional a values make the graph chunk up, right? So you don't have to add any of that. I mean, the first part is sort of a must. The next transformation is the -6, and the -6 makes the graph move to the right. Remember, that's the backwards one. So this one goes to the right 6 units. And then the last transformation is the -3 at the back. And the -3 in the back makes the graph move down 3 units. And you don't have to graph or anything. Again, we're just going to follow the directions. It says describe the transformations. Those are the 3. We describe them and we're out. Okay. So the transformations are fatten, move right, move down. Number 5. I know the first time we went through this on the first practice that it was a little bit new, some of the vocabulary, but we're pretty good at it now. Which number is going to represent the amplitude? Yeah, and I still don't like the use of this word, but it is on the district test, so we're going to just play nice here. So the amplitude is, I mean, you can put -2. Technically, like if this were a trigonometric function, which not all of you will ever maybe see, I don't know, but if you do go on and do any sort of trig, we would just call the amplitude 2. So I'll do here I'll just go with -2. Basically, all I'm asking you for there is just go ahead and just tell me it's the A value and show me that you know that. It's fine. So let's make a quick description because it does say to describe. So what does the -2 do to the graph? Yeah, so it makes the graph, so the graph opens down. And what else does it do? It makes it skinny. So let's be a little bit more specific. Let's say that the Y values go down twice as fast. And again, you can add that comment like Kason said that because it goes down twice as fast, it does make the graph skinnier. Okay. Kind of looks like skimmier. My ends are a little bit connected there, but you get the idea. So, all right. So that's the amplitude number. The y-intercept, you guys hopefully know this by now. How do you find a y-intercept? That's it. And that gets you through any teacher, anywhere, any school asking you that question. The answer literally never changes. You change x into 0. So just up here where this little purple arrow is pointing, you just make that x into a 0 and then do a little bit of math. So it's going to be -2 times, and then in the parentheses, if you change x into 0, what's 0 plus 2? And then you square that. What's 2 squared? So it's -2 times 4 plus 5. And then the math from here should be simple. What's -8 plus 5? -3. So the y-intercept is at the point 0. It's always going to be 0, of course, because we made x into 0, 0, -3. Okay. The vertex is not something that you have to do any math to find because this function up here is written in vertex form. So the vertex just like falls right out, huh? What is the vertex? Not 2, 5. It is -2, 5. Because remember, the x's we're trying to center there. We're trying to make symmetry at 0. So you always want to make the parentheses equal 0. So -2, 5 is correct. And the symmetric point, quite frankly, I would hold off and not answer this one until I start to build the graph. So the symmetric point really is only useful, as far as I'm concerned, if I have a graph so I can look and see it with my own little, logical thought process. So first thing I'm going to do is graph the y-intercept, and I'll keep the colors the same. So the y-intercept is down here at 0, -3. The vertex is at -2, 5. And so the logic is that if the red point is the vertex, you can say with 100% certainty that this green dot that I'm about to make is the symmetric point. Like that is irrefutable logic because parabolas have symmetry. And so if this purple point is 2, so like this little green dotted line that I'm drawing, that's like the center. We call that the axis of symmetry. So if the purple dot is 2 to the right of the axis, then the green dot has to be 2 to the left. And so the symmetric point, we can now go down here and name. I can say that now the symmetric point, like I know who you are. What are his coordinates, the green point? -4, -3. Okay. And then it does say to sketch a graph. And so I think that like for us, we can do a little bit better. When we get to problem 9 and we're just sketching in the middle of nowhere, then we'll probably have a little more chaos and sloppiness. But I think we can hold ourselves to a standard here. There's a couple more points that would be really easy to fill in. Because you guys know that the amplitude number, the -2, tells us that the graph goes down twice as fast. So we know, because we took a quiz on this, that if we go out 1, we go down 2. So you can add a couple of additional points. You will not have enough room to do any more points because if you go out 3, we've already gone out 2. Those points were done with the vertex, or not the vertex, but the y-intercept and the symmetric point. But if you go out 3, you'd normally go down 9, but double 9 is 18. And you don't have enough room to go down 18. Those points would be like down there somewhere, kind of where I'm making those dots. So at this point, your only job left to do is to make the actual graph, and I'm just going to make a mess of this. So there we go. Oh my God, that's terrible. Um, I don't know why I added a dot right there, but I'll get rid of that. So that's what number 5 is all about. So do you have any questions about any of those 4 parts? All right, then page 2 we go. Number 6. Our job on number 6 is just to go through and simplify, and then we'll worry about the whole imaginary thing for problem 7 when we're done with problem 6. So for problem 7, I personally would break this up into the square root of 100 and the square root of 7. And you'll notice when I do that, I take the negative out because I just know I'm going to put an I in my answer. So it's all good. So this becomes a 10. And then I insert the I, root 7, and I'm done. That's all. Okay. Question number, well, the second one is not imaginary or anything. In fact, the negative really is relatively inconsequential. Like I'm still just going to tackle the square root of 48 like I normally would. And we've seen this number enough times that we know it's 16 and 3. 48 is one of those numbers that pops up, and people are inclined to say things like 4 times 12, 8 times 6, and those are all pretty, nah, don't do that. Go big or go home, right? So this becomes 4 root 3, and then you just take the negative and stick it on the front, and you're done. That's all. The negative, like I said, really has no purpose here. The key to these next problems is to really identify what I powers are. Clearly, that's a hot topic on this little section, is we want to know if you know what I to the second and I to the third and I to the fourth are. So do you guys all know what I to the third is equal to?
Mhm.
It's negative I. So if I change I to the third into who he actually is, then this problem can be rewritten as negative 15 times negative I. And then at this point now, it's just basic, like 8th grade algebra kind of thinking. And that is, I have a negative times a negative, which is a positive. So the answer is just 15I, like done. The key to getting through this section of the test is to understand that everyone is a separate entity. I know they're all connected, but like you have to treat them all separately from each other. And so on this one, what I'm going to do is I'm going to isolate again the little purple jelly bean here. What is I to the fourth? It is 1. Yeah. And so then I just think, oh, this is just 12 times 1, which is just 12. Pretty hard to miss. All right, in the next row, I have 3 entities. So I'm going to separate them and give them each like equal amounts of consideration. So first off, there's the -3, which I'm going to just kind of put in timeout right here. And now I'm going to leave room for what the answers are to the other 2 pieces. And the other 2 pieces are this one. This one's really new. I mean, not new, but really recent in our memory. What's I to the third again? So I'm going to put negative I right here. And then you should, by this point, the end of your Algebra 2 year, be able to break down the square root of -20 in your head. Anyone want to shoot it? Go for it. Say again? Okay, that's fine. So that's a good work step. So if you want to break it up, you can break it up into 4 and 5, both roots. So it becomes 2I root 5. So if you don't understand that, now would be a good time to ask. But I want to reiterate what I'm doing is I'm treating the -3 on its own, the I part on its own, the radical on its own. And then in the end, those parentheses, I'm just going to bring it all back together. It's a big old happy love fest of multiplication and just see what happens. So first off, the -3 and the two numbers with the green arrows pointing at them, those are both what we call rational numbers. So we're going to grab them, detach them, and create their own sort of little answer, and that's going to be -6. But then we also have a pair of i's. So there's a negative I here and a positive I here. And there, you can think of I at this stage like a variable. Of course, we know it's not. But if I gave you like -x times x, or -r times r, or -j times j, what are the answers to those? Not zero, we're not adding. First one's -x squared. What's the second one? -r squared. What's the third one? -j squared. So don't forget, like fundamentally, we understand that the negative of something times the positive version of that something is just a negative of that something squared. You buy it? So I can add in here a negative I squared. And then we're not quite done yet because we've still got some things that need to be uh, dealt with. Not some things, just a couple. I do like, so I'm not done yet. This is a fun problem, I think. I mean, you might not think it's very fun, but like, what does this red jelly bean equal? Not one. It equals -1. But like knowing that I squared is -1 is necessary, but then you got this extra negative right there. I just pointed to it. What's the negative of a -1? A 1. So in reality, that second set of parentheses winds up meaning nothing. It just goes away. Because like if you put 1 into a multiplication problem, it's like, I got no purpose here. So we wind up with a final answer of -12. Oh, we have another I there. Did I miss that? I Oh, but that's fun. I gotta get away with being a turkey, a lazy turkey. This I that I'm circling right here, that was neat. That was kind of an accident. Can we all agree that it's just gonna sit there because these ones just kind of destroyed themselves? So our final answer is going to be, I missed that, but that worked out okay. So we're going to wind up with -12 I root 5.
Why didn't we get rid of it in the first step?
In this step right here.
So that step we multiply them.
Oh, we already did multiply them. That's right. So he's not there anyways. Oh, my bad. So never mind.
Then you multiply that one with the 30 and to make the 6.
Yeah.
Yeah, what's wrong with me?
Oh no, you're really.
Maybe I'm out at the track meet with everybody else. Golly, what a slacker. So yeah, that's not even, I wasn't even close. What a goofball. So the answer just winds up being -6 root 5. Golly, apologies for that dumpster fire. So I would say, do you have any questions? But after an explanation like that, that seems like a moot point. So yeah, my bad. Um, good. By the way, there's not a question like that on the test. So surprise, surprise. I just added that because I thought it would be a little spicy. A little too spicy for this guy. Maybe more coffee or more sleep or just a couple of days off or something. I don't know. So we're on to the next one, and this is just a straight up power of I problem. So these are the ones where you guys grab your calculator and you type in 1242 divided by always 4, and you'll get a remainder of 0.5, which if you do this kind of math without a calculator, you know that that means that the remainder is 2. But again, according to your calculator, it's going to say blah, 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 0.5. And a remainder of 0.5 means that it's actually the same as -1. So the answer to this one is just real simply just -1. All right. On to the third one in the bottom row. Had someone yesterday ask me if these cancel out or something. I was like, well, no, they don't cancel out. What the heck kind of question is that? -8 is just in timeout, so we ignore that. And then we just break down the square root of -8. So we would use a root 4 and a root 2, which is going to become 2i root 2. And then that becomes, just sits there and waits to be multiplied by the -8. So we wind up with -16i root 2. And then the last one is this one should be pretty simple. compared to that dumpster fire on the left. I squared is what? -1. So what's -6 times -1? Good. So question 7 just asks us which answers or which problems are imaginary. And to be imaginary, you have to have an I left when you're done. So like, just because you have an I doesn't mean you're imaginary. If the I sort of eliminates itself in the process, then it's not really an imaginary number. Okay. So the imaginary numbers are going to be the ones where we're stuck with I. So I would just list them in their OG form. So I would say like the square root of -700 is imaginary. The next one that has an I in it is -15I cubed. The next one that has an I in it is the -8 root. That problem is so was freaking me out. The last one is the -8 root -8. So all the other ones, they turned out not to be imaginary because at the end the eyes sort of pieced out, right? So any questions on that? Okay, question 8 is a quick one. I hope that you find success with this. The first thing I want to do is write the vertical motion model. And because it says meters, and I think on your photocopy, I made a typographical error. I think that I probably told you this yesterday if you were here. I have a rock is thrown upwards, but I made photocopies before I edited this. Right here, that where I'm underlining, do you guys have the word ball? Yeah, that's because I forgot to edit that word when I was making a new version. So whoops, it's supposed to be a rock. To me, that'd be a really weird question if I tell you about a rock being thrown upwards and I ask you some random question about a ball. So clearly that was just an oops. So I want to write the vertical motion problem or model. And because it's in meters, I'm going to use the number -4.9 for my model. So remember, if it's feet, we use -16. If it's meters, we use -4.9. So we're going to say the height of the ball, the height of the rock, is equal to -4.9 times squared plus initial vertical velocity times time plus original height, which we use S for that for some odd reason. I guess it makes sense because we couldn't use H again. And we couldn't use I because that's a number. So I guess it makes sense. So there you go. So now we're going to plug stuff in. So we know the initial vertical velocity is 30. So we can modify our model now to say H equals -4.9 t squared plus 30t. And then we know the initial height is 2. It says right here, it was thrown upwards from a height of 2 meters. So we can just put a +2 at the end. So the goal is to get to that point where you can say, that's my model for this problem. Going forward, ask me anything you want, and I'll use that equation to answer your question. We want to know how long does it take for the rock to reach a height of 35 meters. So what are we going to do? Put 35 right here where H used to be. So I'm just going to swap that out, and I've got myself a quadratic. This is definitely a quadratic formula problem because it's got the middle term. The ones where we drop an object are easier because I don't have the middle term. So that's okay. We're not scared. So I like to move everything to the side where the green jelly bean is positive. I don't like using negative A values. It's just a common practice. So what I'm going to do is I'm going to migrate all of my terms over to the west side. So I'm going to call this 4.9 t squared minus 30t plus 33 equals 0. You don't have to, but the quadratic formula sometimes confuses people when A is a negative number. So as a good practice, you're always in control. Any quadratic equation in the world can be swapped, switch sides so that A becomes positive. We're so used to that, but I leave that up to you. So you might think I'm crazy for a load of reasons, including that. So I'm going to plug all this into the quadratic formula, and it's going to say my time is equal to the opposite of B, so 30 plus or minus, and I'm going to need my calculator for this for sure. B squared, I can handle this one. 900 minus 4 times blank, all divided by 2 times A, which is, of course, 9.8. And in place of those, the blanks, those are my A and C. So I'm going to put in 4.9 for A and 33 for C. So get the calculator out for its first usage of the day here. Boy, it's dark in here. This is going to be hard to see. Say it again. Okay, I'll take it. Thank you. So this is now, here are my two answers. Time equals 30 plus the square root of 253.2 divided by 9.8. And then my other answer is, I'll switch colors here. Time equals 30 minus the square root of 253.2, all divided by 9.8. We've seen three possible scenarios. We've seen scenarios where we get one answer that makes sense and one that's stupid. We've seen scenarios where we get two answers that both make sense. And we've seen a scenario, assuming you completed assignment 50, where there are no answers that make sense. And the upshot there would be if we get a negative square root, which obviously we didn't, but if we get like a negative time, then we would omit that because that would be an implication that we'd have to go back in time, which we don't do. So we're going to type both of these things into our calculator. I'm just going to type them in. I appreciate you. So I'm going to do for the first one, 30 plus the square root of 253.2. I'm going to make sure I hit enter after that step. And then I get some number that I don't really care about. And I'm going to divide it by 9.8. And my first answer is 4.68. And that's rounded. So my first time is approximately 4.68. And I say the first time, and actually that's a lie because it's the second time, but it's the first answer. And then I'm going to do that again. I'm going to do 30, but this time I'm going to do minus the square root of 253.2. Again, I'm going to make sure I hit enter, get some number that I don't really care about. I'm going to divide it by 9.8, and I'm going to get 1.44. Make sure you round correctly. So I would say that the rock reaches that height twice. And we've talked about this, but I have to ask you, why does it happen twice? Right. It crosses through a height of 35 feet once on the way up. And then, of course, on its way down, it crosses through again. So I would just say that the rock passes through at, and you don't have to write a complete sentence, but I would just put like 1.44 seconds and 4.68 seconds. You can write a complete sentence if you want to, but I don't need that from you. Make sure you label your answers, okay? Any questions on that one? Okay, then let's get to, why do I have a duplicate of that? And I'll get rid of that. Bam. So this is the last question. And so this is one where, so we got Sarah with a potato cannon, which is pretty awesome. Bless you. And what we're going to do here is we're going to write points. So my first point is going to be 1 second, height of 87 feet. My second point is 2 seconds, height of 127 feet. And my third point is after 3 seconds, the height of the potato is 135 feet. And the key to this problem is understanding that what you're going to do is you're going to plug numbers into this equation, the general standard form of a quadratic. So y equals ax squared plus bx plus c. So over and over again, what we're going to do is, and we go kind of one at a time, we're going to take the first point and we're going to put 87 in place of y, and we're going to put 1 in place of x and other x. So my first equation, your first equation should say 87 equals a plus b plus c. Because if you put 1 in place of all the x's, they really are inconsequential. They do nothing. And then our second equation is going to be 127 equals 4a, because that's 2 squared, plus 2b, because that's just where the x goes, plus c. And then our final equation is 135. equals 9a plus 3b. Do you have any questions about where those numbers are coming from? Okay, so at this point, we would solve the system. And what I like to do is just take the top equation and multiply everything by a negative. So it's going to be negative 87 equals negative a minus b minus c. And I'm going to swap out the old version with the new version. And then you've got a very simple system to solve by elimination. Always take advantage of the third column. The C's are just waiting to be utilized. So if I do row 1 plus row 2, I get, what is that, 40 equals 3a plus b. And then if I do R1 plus R3, because that's the only other combo that will eliminate, it's going to be 48 equals 8a plus 2b. So this is just a real quick side trip down how do I solve a triple system road. I'm going to multiply the top row, of course, by -2. Like any other decision would just be more work. Like, why would we do that? And we're doing that to eliminate the b's, right? So we get -80, -6a, -2b. And then when you combine those two that I just bracketed, then you wind up with -32 equals 2a. And the b's, of course, cancel. So we figured out just now that a is -16. It's not a big surprise. And then to find b, you have to find b next. You have to put -16 in place of a. So the only green writing on the screen, I'm pointing at something, I would go right there and put in my -16. That's the easiest equation I can personally find on the board with a's and b's and no c's. So what it's going to say is, I'll just kind of write it over here in green. I hope you can see the green. I know it's annoying. I wish I could make it darker, but I can't. So it's going to say 40 equals -48 plus b, because I did 3 times -16. And then if I add 48, I figure out that b is 8. And then if you plug everything back into the first equation, you remember the first equation? It was awesome. It was 87 equals a plus b plus c.
Wouldn't it be 88? Yeah.
I knew that. I'm just testing you guys, making sure you're good. So if we plug those, so if we plug those in, so if we plug those back in to the first equation, yeah, good thing you guys are watching me today. The a plus b would make 72. If I subtract 72, I think I get 15. Did I get it? Yeah, you better double check me, all of you collectively. Putting -16 and 88 into that equation that I just circled. -16 plus 88 is 72. And if you subtract 72 from both sides, you get 15. I feel good about that one, 15. So at this point, like, you would never do what I'm about to do, because I have to write a little bit bigger on the board. But at this point, I'm going to erase my work. Don't you dare. And then I'm going to write my answer, because the answer to question A still is not on the board. The answer to question A is y equals -16x squared plus 88x plus 15. Okay. Which leads us to part B. This will be where a lot of the issues probably will start to arise. And I do only have 5 minutes, so I'm going to try to go a little bit quick here. The key here is to figure out that's such terrible timing. Unbelievable deal. So to sketch the graph, the first thing we want to find is the vertex. And the vertex is going to be at -b over 2a. So that's -88 over -32. And I'm going to type that into my handy dandy electronic calculating device. -88 divided by -32. I got 2.75. So that means that the vertex is at 2.75, comma something. And to find the something, I'm going to put it back in the original equation. So I'm going to go -16 times 2.75 squared plus 88 times 2.75 plus 15. I got it. 136. So the vertex is up here at this number right here. So when you make a graph, you know, knowing where the vertex is going to be pretty essential. So you can just make your graph look like this. And I want to go up to probably about 140. So I'll just go up to like 140. And then I'm going to cut that in half, put like a 70 here. And you don't have to be very exact with this, quite honestly. So I put a 35, and then half of that is another like 105. And so you would probably put more detail, but the clock is telling me to hustle my bustle. And that phone call didn't help either. So I'm going to label this one over here with just seconds. Like, I don't think I'm going to need a ton of seconds. So 1, 2, 3, 4, 5. And you'd label those, but I don't want to right now. So you'd put like height and time and all that. So the vertex is here at 2.75, 136. I'm going to estimate that that's probably right about here. Okay, the next thing we have to do is find the y-intercept. And to find a y-intercept, it's just put 0 in for all the x's. So the y-intercept is obviously at 0, 15, because the x's just destroy the whole equation, really. And so I'm going to estimate where that's at, and that's probably right about here. Right. So the sketch of the graph is pretty much done. Like you could find a symmetric point over here someplace. It's going to be bare almost all the way off my graph, probably right about there. So then the graph itself would go something like this. Got that? So the key there is the vertex, the y-intercept, and I would find the symmetric point. If you watch the other video, I'll go into more detail about that. But the coordinates of this, the point way over here where I'm moving my little pointer, I would find that if I were you. But again, I've only got about a minute and a half, so I'm gonna hustle. Good. Okay, so the last problem, the potato flies into a well and hits the bottom 6 seconds. I'm just going to go up to my equation and I'm going to change all the x's into 6. So that just means if time is 6, then I just replace all the x's with 6. And so I'll type that into my calculator. So I'm going to do -16 times 6 squared, which is 36, plus 88 times 6 seconds, plus 15, and I get -33. So what that means, since the height is at -33, it means that what is it, a well? The well is 33 feet deep. So aside from an interrupting phone call and a couple of hilarious mistakes, we made it with exactly 18 seconds to spare. So like I said, I have another video of the first district assessment practice. So you should have all the tools you need at this point in time. Test is Tuesday, right?
Yep.
And we're all going to be ready. Okay, awesome. If you need me, flex today, lunch today, after school today, I'm going to be here. So let me know. Bye.